second position, we should have 4. Okay. What type of factoring is this? The x, right, Quentin? So we're going to do the x thing. So we're looking for what multiplies to negative 30 but adds to 7. And what are the numbers that do that? Yeah. And then what do we write in the parentheses? X plus 10, x minus 3. Okay. Are we having any trouble typing the functions into the calculator? Are we able to type these in to Desmos? We're good? So how do we type in a cube root? CBRT. So I'm going to go to Desmos, CBRT. Make sure I'm underneath to type x minus 4, and then get out of that to type the plus 2. And what is the locator point that I'm going to graph? You're close. 4, 2, perfect. 4, 2. So that's what I'm going to look at the table. When I put the table up here, I'm going to look for 4, 2. It's not on the screen right now, so I'm going to make my table a little bit bigger. There's 4, 2. And then there's some points on either side. So I can graph 3, 1, and I can graph 5, 3. Those are some points that I can graph. And on the right side over here, I think these are going to be decimals. I can see what they might be if there's any more number. Nah, those aren't really going to be anything. But maybe I can graph some on the left. So let's double check and just see if we've got some over here. So negative 2, negative 3, negative 4. We can graph that one. Negative 4, 0. Negative 5, negative 6, negative 7. Yeah, so just negative 4, 0. We can graph that one. Okay, so that's what I've got. So really these ones are just annoying to find the tables because there's so many decimals here. Okay. And then the next one, negative 3, x minus 1 to the third. And then a plus 6 on the end. There we go. Okay, so what's the locator point for this one? So over 1 up 6. Okay, and so I'm going to look for that on the table. There it is, over 1 up 6. And then it looks like I can only graph 1 point on either side. I can't even graph that one. 0, 9 doesn't even quite fit, but I'm going to make it fit. So 0, 9 would be right here. And then 2, 3. Okay. So it looks like this.
When you ask for the intercepts, do you want the y-index intercept?
Yeah, if it just says intercepts and it doesn't tell you which one specifically, then you have to find both. Yeah, that's a good question. Okay, what are the transformations down here? Okay, we're going to reflect over x. You're close. Left 7. It's always opposite. Yeah. Left 7 and up 1. Okay. What's the locator point for this one? Negative 7, 1. Okay, and then we got a graph to find the other stuff. So I need to type in a square root. How do I do that?
Go to the keyboard.
SQRT, or you can go to the keyboard. You can grab it from there. So x plus 7.
And then space.
And get out of there and get a plus 1. Okay, and so there's our graph. We got an x-intercept right there and a y-intercept right there. So I'm going to mark down what those are. So x-intercept is negative 6, 0. Y-intercept is 0, negative 1.646. So I'm labeling what each of those are. And then for the range, we could see that the picture kind of went down like that. My picture's not great, but kind of went down like that. So is the range x values or is it y values?
Why? What's my value?
It's y values. So domain is x, range is y values. So what is the y value right here? 1. That's the locator point, so that's a y value of 1. What's the y value for this arrow?
Negative.
Negative infinity. If it was an x value, it would be a positive infinity, but it's a y value, so it's a negative infinity.
Negative infinity, comma, 1 bracket.
Yep. So we go down to up for range. So we're going to go negative infinity to 1, down to up. We put a bracket around the 1 because it's an actual point. We can see it on the graph. We can put our finger on it. If I'm looking on Desmos, I can actually see it. The point where the y coordinate equals 1 is right there. Okay. How do we feel about that stuff? Good? Feel good? Okay. All right. Let's go ahead and put those off to the side. Have we turned in our assignments from yesterday? No. Okay, we're going to make sure we... like we were working with the last couple days. And today we're doing function operations. And operations you have worked with before. We are adding, and we are subtracting, and we are multiplying, and we are dividing. So when you do function operations, you're going to take two functions, you're going to add them together, or you're going to subtract them from each other, or Quentin, you're going to multiply them, or Quentin, you're going to divide them. You should probably just move that cell phone all the way, maybe in your bag. Okay. All right. Chromebook off the table completely, all the way in your bag, somewhere else. You can put it back on the chair, somewhere where it's not even on your desk. I don't want it to be open at all. All right, so the first example says we are adding two functions together. We're going to take function f and we're going to take function g and we're going to add them together. This is a special notation that just means that you're adding f and g. It's a very common notation. It just looks a little weird. So when they write something like this, what they really mean is they're just saying take f of x and add it to g of x. That's what they really mean. So these notations, they mean the same thing. They're just saying take f of x and g of x and add them together. This is just another way of writing it, okay? So it is not telling you to multiply by x. It is not telling you to do that. It's just saying take f of x, take g of x, add them together. So I'm going to take f of x, I'm going to write it down. 3x minus 8. I'm going to take g of x, I'm going to write it down. Negative x squared plus 9x. Now here, because I don't have a number in front of my parentheses, I don't have a number here that I should be distributing. There's not like a 2 or anything. There's no negative in front of my parentheses to distribute. Because of that, I don't technically need the parentheses. So we started off putting parentheses around it to show that this was one function and this was another function, but the parentheses aren't really necessary. So I'm just going to erase them since I technically don't need them for this problem. And then when I add two functions together, I just combine like terms and I put them in the correct order. So which of these terms do you typically write first? The x squared term usually gets written first. So I have negative x squared. I'm going to write that first. Then what else do I have? I'm going to add the 9x and the 3x and I get 12x. And then I've got negative 8, and I'm done. So my final answer is negative x squared plus 12x minus 8. Finished. All right, the next one is written in that kind of weird notation again, but it really just means start with h of x and subtract k of x. That's all they're asking us to do. Start with h of x and subtract k of x. So I'm going to write down my h of x, which is 3x minus 2. And I'm going to subtract off k of x, which is x minus 4. And when I'm doing subtraction, I have to be careful because here I've got a negative in front of parentheses. And if you have a negative in front of parentheses, what do you have to do with the negative? You have to distribute the negative. So this part right here can just be rewritten. There's nothing in front of those parentheses that needs to be done. But over here we had to distribute the negative. And so what do we get? Negative x, positive 4. So negative times x is negative x. Negative times negative 4 is positive 4. Okay? And then if we combine our like terms, what do we get? 2x plus, and then what do we get for this? Not 4, 2. Perfect. Okay. The next one says m and q are what we're going to add together. So we're going to take m of x and we're going to be adding q of x. So m of x is x minus 9. Q of x is x plus 1.
I have a question.
Uh-huh.
How are you getting these numbers?
They're up at the top.
Oh,
At the end? I'm just combining like terms.
I was like, how are you getting these numbers?
They're at the top.
Oh, okay. That makes more sense.
Mhm.
I was confused. I was like,
Yeah, they're all listed at the top here. So m is from right here, x minus 9, and then q is from right there, x plus 1. And then do we really need the parentheses around this one? We don't really need the parentheses. So we've got x minus 9 and x plus 1. And if we combine our like terms, not x squared, if you multiplied them, you'd get x squared. We get 2x. X plus x is 2x. Negative 9 and positive 1 is negative 8. Okay. For the next one, we're going to take function p and we're going to subtract off g. So p of x minus g of x. So function p is right here. Negative x squared plus x. Minus function g. Function g is right up here. Negative x squared plus 9x. Okay. And what do we do with a subtraction problem? We distribute that negative. Okay. Okay. Plus x squared minus 9x. Okay.
and then you get x minus 9x. No.
Yeah, what happens with the x squareds?
Negative 8x.
Yeah, these x squareds cancel out. We have a negative x squared and a positive x squared. Yeah, we've got a positive 1x and a negative 9x. And that gives you a negative 8x. That's just the answer all by itself, yeah. Mm-hmm. Okay, I want you guys to see how you can do with the next one. It says f minus m. Let's see how we can do with this one, f minus m. So see if you can write down the correct functions to subtract f minus m. Mm-hmm. We got to get to multiplying stuff too. If you work fast, you can work on your makeup work too. All right. Have we gotten an answer? Yes, yes, yes. Is that the answer we got? Yes. All right, let's try the next one. H minus Q We think we got it? Yes? 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 You gotta wait till Zion comes back. 2x minus 3? Yes? So we had Q was x plus 1. We distributed our negative. We got negative x and negative 1. And then 3x minus x is 2x. And a negative 2 and a negative 1 makes negative 3. All right, after this, we move on to some other problems. They've got a dot in the middle. What does it mean if they have a dot in the middle? Multiply, yeah. So we're going to do f of x multiplied by h of x. So I'm going to look above. F is 3x minus 8. So I'll write that down, 3x minus 8. H is 3x minus 2. And when I multiply two sets of parentheses, what's my method? How do I do it? Starts with an F. Not factor. Foil, yeah, it's foil. So we're going to foil these. first, outside, inside, last. So the first times the first is 3x times 3x is 9x 9x squared. Perfect. 9x squared. And then the O is the first one times the last one, so this is the outsides. 3x times negative 2. What's 3x times negative 2? Negative 6x, okay. Then the inside, so this one times this one, the insides. And it's a negative times a positive. So we're going to have negative 24x. And then L is the last. So this one times this one would be the last times the last. Negative 8 times negative 2 is positive 16. Perfect. So we've got 9x squared. We've got positive 16. Then what's in the middle? Negative 30x. Perfect. Okay. What is the next one? It's not multiplication, it's... Yeah, it's division. M of x divided by k of x. And students usually really love this one because you just write it like a fraction and you're done. So m of x goes on top, x minus 9. K of x goes on bottom, x minus 4, and we are finished. Yeah, that one's done. Made my line kind of long. Okay, so this one's all finished. This is... That one's nice. Okay. All right, next one, Q times M. So Q is x plus 1. M is what? What's M? X minus 9. Okay, and we're going to FOIL. So F, first times first. What is that? X squared. Okay. O is the outsides. What do I get when I multiply the outsides? Negative 9x. I is the insides. What do I get when I multiply the insides? Plus 1x. Okay. L is the last. What do I get when I multiply the last? Negative 9. Okay. And if I add them all together, what do I get? Perfect. That was a typo though, right? Because negative 9. Okay, next one's our favorite, division. What goes on top, what goes on bottom? N is on top, so what's on top?
X squared plus x.
Okay, x squared plus x, and then
3x minus 2.
h is on bottom, 3x minus 2, we're done. Okay, next multiplying one, h times q. I'm going to have you guys multiply this one. H times q. How are we doing? We got it? Did we foil it out?
No.
We got a few people done. Everyone got their answer? Close? Daniel's next, and then you can go after him. All right. This is what we should have gotten. Is this what we got? Getting close. All right, and let's do our division problem, our last division problem. Something's got to go on the top, something's got to go on the bottom.
X minus 9 for
X minus 9. 3x minus 2. All right. So we just got to pay attention to what they're asking us for, which functions they're asking us to use. Okay? The biggest thing we got to watch out for is we got to see if it's a subtraction problem, we have to make sure we distribute our negative. If it's a multiplication problem, we have to make sure to FOIL. Does that make sense? We got to watch out for those two. All right. I'm going to hand out the assignment. I'm also going to try to get your old assignments back to you, especially ones that might need a late pass. If you turn them in without a late pass, I need to get those back so you can get a late pass turned in. And then I'm going to try to catch up on grading the stuff you guys have turned in lately, so we all know everything. I had updated all my grades before I got married. So everything up until it was, so I'm a week, I'm a week behind. Yeah. Okay, so I'm going to pass these out.